Let's consider two objects, right? Have a look at maybe two boxes. It contains one, two, three, four atoms. Let's call that object A. And here's object B. It also contains one, two, three, four atoms. Okay. Here are some observations that we can make. The mass of A is the same as the mass of B, right? Because they contain the same number of atoms, don't they? The other observation we can make is that B takes up more space compared to A, right? The space taken up by an object is called the volume. Okay, the volume V. So V for B, right? The volume of B is greater than the volume of A. Okay, so because B takes up more space than A. Another observation we can make is that the particles in B are less packed together. Okay, the spaces between them are larger compared to the particles in A. Okay, so we say that they are less packed, less packed together. Now, we've just described the arrangement, we've just described two objects in terms of mass, right? In terms of the mass. We also are able to describe two objects, in terms of their volume. Okay, and the last way that we're describing object is the so-called arrangement. Okay, how are atoms arranged in that object? Okay, there's another way we can describe objects and or compare objects really that has to do with what's known as density. Okay, density. Density just measures how much mass there is in a given volume. Okay, how much mass in a volume. We can write the formula for density as follows. So my density is rho, that is an m, divided by a v. Okay, m here is my mass. Okay, it has many units. It could take on many units. It could be in grams, could be in kilograms, for example. And this v here is my volume. Also, the number of units could be in liters, could be in centimeter cube or even meter cube. Okay, and we're pointing this out because the units of density will depend on the units that you use for mass and mass and volume. So as an example, if I choose my units to be grams and meter cube, then my density here will have units of gram per meter cube. Okay, now looking at that formula, right, looking at that formula, if V is constant, then if I increase M, the density increases. Okay, if V doesn't change and I increase M, then my density increases. Okay, the same way, if V is constant but my M decreases, then my density decreases. Okay, now if, let's do this, if M is constant and I increase V, V increases, then the density will have to decrease. If V decreases, then the density increases. Okay, so here are just some qualitative uh, observations about that formula. Rho equals m over v. Okay, so this equation here is the equation for density. Okay, let's have a look at how we can use that equation in an example. Okay, here we have a an object, currently it's in the water, put it right here. The mass of my object happens to be 31.48 grams. Okay, so let me write that down here. The mass is 31.48 grams. Okay, my vessel here is telling me that I have a volume of liquid 25.5 ml, right, milliliters. If I go and take my object and submerge it here and put it in this vessel, this water level will rise and the volume indicated here will change. Okay, the difference between that new volume and this volume here is the volume of my object. Okay, so I'm going to write down here an initial volume V1 without the object in the liquid. That looks like it's 25.5 ml. V2 is what I'm going to get when I put my object into the liquid. Ta-da! Okay, and it looks like the volume is 29.5 ml. Okay, so with these two quantities, with these two measurements, right, I can find the volume V of the object. Okay, so let's go ahead and do that. Volume of my object is the difference. Okay, and that's 29.5. I'm going to take away 25.5. It looks like that's a 4 ml. Okay, so that's my volume. So V is 4 milliliters. Okay, at this point, we have a mass and we have a volume. Okay, so we can now go ahead and find the density of this object. First thing I'm going to do is I'm going to remember the formula for density. It's a rho mv. Okay, so the next thing I'm going to do is I'm going to think, can I use this equation directly? Do I need to rearrange? The answer is no. Okay, so it looks like I can continue now to substitute. Okay, let's go ahead and do that. My mass is 31.48 grams. Okay, and my volume is 4 milliliters. I can do the math. I'm going to take the numerator divided by the denominator. It looks like I get 7.87. All right, 7.87. Now have a look here. Here's where the units come in. That's my G divided by ml. So the units here would be G divided by ml. Okay, and so our final answer is, well, what's the density of this object? 7.8 7.87. Why is that an L? I think it's 7.87, right? Grams per milliliter.